x's of a function, the set of all input values. So what's in parentheses is just a reminder of what the input values are. They're your x values of a function. Okay, and likewise, the range is a set of all output values. And look how I put the output values, f of x's, instead of y's. Remember, we've graduated to a higher level of mathematical understanding and communication, where the y values are f of x values. The set of all output values, f of x's of a function. Okay. This is a good drawing because it tells you what the range is and what the domain is just by looking at a graph. So the domain is what your x's can be. Look at from here to here. X can only be any number from here to here because that function stops. Okay, it stops. It doesn't have an arrow. And the range can be any y value from here to here. See, that's your range. What can your f of x's be? Like here's your range. What can your domain be? There's your x's. I'm going to copy that down and give you a minute. Okay. You got your x and y axis. So end behavior. Let's go ahead and describe this end behavior-wise. So we'll first talk about the end behavior, minima and maxima. I'm going to talk about that right now, what the heck that is. And then domain and range. So draw the graph and then make these like bullet points here. Let's comment on each of these features. These are features of a function, characteristics, if you will. Okay. First one, end behavior. The more I go this way on x, as x approaches positive infinity, where does the function go? As x approaches positive infinity, where's the function going? Positive infinity. Because look at f of x is, here's your number line for f of x. This is positive infinity. So as x goes to positive infinity, the function goes to positive infinity. So there's my first slide. Look at it. F of x approaches positive infinity as x approaches positive infinity. The graph is just telling us that. That's review. So this is review right now, the end behavior part. And so how about this going this way? As x approaches this way, the function is going to negative infinity. So the function is going to negative infinity as x approaches negative infinity also. Minima, maxima. Now, what is the highest point and the lowest point of this graph? Kind of a trick question. Right, the highest point would be infinity, huh? It goes on forever. But what would be a peak? It just in this nearby area, what would be the highest point? Right here, huh? This would be what we call a maximum. But is it the absolute maximum? No, because the function goes to positive infinity that way. In other words, there's function values that are way higher than this maximum, this little hill, this peak. So we would call this a relative maximum. Go ahead and put an arrow here, put relative maximum. Why the word relative? Let me talk about the word relative. Go ahead. What do you think? Why did I say relative maximum?
That's what we have.
That's what we have right now. And this is the maximum in relation to this environment of the function only. The absolute maximum is if you keep going this way on x, it's going to positive infinity. But just in this area, in relation to this area, look at in relation, that's why we got the word relative. The highest point in this area, this environment, is this point, which is negative 1, 1. So I'm going to put relative minimum, relative max rather. Relative max, we'll abbreviate maximum, just put relative max is negative 1, 1. The peak. But it's not the absolute maximum again. It's relative. We got the domain. So right here, real quick, Garcia, you have parentheses instead of brackets. Sometimes when we state the domain, we're going to use brackets, but that's going to come in our next example. There's a difference of meaning between brackets and parentheses that I'm going to get into shortly. This is part of the new learning that you need to be paying attention. So the domain is x can be any number between negative infinity and positive infinity, but actually never becoming negative infinity. Because we can only approach infinity, we can never realize infinity. That's a philosophical statement there. There's no such number as infinity. It's just something, it's an idea that we approach. So that's why we put this parenthesis. X can never actually be negative infinity or positive infinity. How about the range? Is there any values that f of x cannot be? We're looking at this now. Can y, or f of x, remember they mean the same thing. Is there any values of y that don't exist? There's none. Look at the one previously. Look at this right here that you did. The value of y can be anything in past this little zone here. There's no values of y out here. Look at the function that, and any values below here, there's no values of y. The function just goes from here and stops. Look at it. It stops here and stops there. There's no values of y beyond this range. So looking at this one, this goes to negative infinity and positive infinity. So y, the value of y can be any number. So we're going to do the same thing for the range. Y can be anything from negative infinity to positive infinity. I'm going to put that there. So the range is from negative infinity to positive infinity. Forgive my negative infinity. Looks like I hate it there. So look at some new concepts today. Minimum, maximum, domain, range. One more example, and we're done. I'm going to copy this one down. Pay attention to this graph, how it stops. It begins and stops. It doesn't go on forever. I'm going to copy that down. Last example, example 2. All right, so what's the end behavior like? The function, as we go this way, the f of x approaches. What would this value be? Look, it stops here. What would this value be, the f of x here? This value. So this point right here, what would the f of x value be here? X would be 7, but what would be f of x here? Remember, f of x is your y, right? This is your x and f of x. So what would be the f of x value right here? Somebody help me before I cry.
0?
0, huh? Isn't that 0.70? So look at the end behavior now. It's not going on forever. Look at the function approaches 0 as x approaches. Right, it stops. So x approaches 7 and it stops at 7. So f of x approaches 0 as x approaches 7. That's one end. How about coming this way? Put that 0 again. F of x approaches 0. Look at as x approaches what?
0.
But x can't go negative. It stops right here. Look at the function stops here. So as x approaches 0. So x stops at 0. It approaches and then stops at 0, and the function approaches 0 too. So there's your end behavior. A little bit different now because the function's not going on forever. It has a beginning, it has an ending. How about minimum and maximum? So this point right here, would that be an absolute maximum or a relative maximum? Give me an argument. It's higher than everything, huh? Or yeah, this one example, one argument, and yours is what? Right, it doesn't go on forever. There's no higher point in this whole function than that point. It starts and stops. This is the highest point, so we'll just call it the maximum. Not relative, but absolute maximum. Absolute max would be 1.5, 0, huh? I'll put 1.5, 0. And the minimum, absolute or relative? Absolute minimum, right? Would be, let's see, about 5.5, -2. Oh, my bad. You know what? This maximum is wrong, huh? It's 1.5. What's the y value there? 4, huh? 1.54. Forgive me. What's the matter with me? Need more coffee. Big time. All right, so how about absolute minimum? I'll just put hash marks as absolute minimum. So these hash marks just mean absolute. Same thing I went before. So absolute minimum would be 5.5, -2. Exactly. It's about 5.5, right? 5.5, -2. That's cool. As long as you're in the ballpark, you're good. So 5.5, -2. Domain. What can x be? So x can't be every number. Look at, we start here and there. What is the domain? 0 through 7. Now look at the what? Look at the. I'm not going to use parentheses. I'm going to use bracket now. Look at. X can be any number between 0 through 7. Bracket. So the bracket means x can be this number. X can be 0. You see. As opposed to parentheses, the previous example. Think of the previous example, we used parentheses because x can never be infinity. We can only approach it. How about range? So the range is your y values. The possible y values is from here, -2 to +4. Brackets though, because the function can actually be those values. Okay. We're done with our notes for now. Now.